So number one free response, I wrote out what information was given me, and the equation that I'm gonna be using is m red velocity initial plus m blue velocity initial equals m red velocity final plus m blue velocity final. So I'm gonna plug in what is given. So this is 15, this is 5, that's 7 for the blue, and negative 2.5 because the blue car moves left at 2.5 meters per second. So if it moves to the left, it's gonna be negative. That's what I did wrong. I didn't put that. I put negative. I put a positive on the test. That's why I got it wrong. And I used like wrong numbers. And I used the wrong formula and stuff too. And so yeah. That equal to 15 velocity final plus 7 of the kilograms of the blue, and then the 5.17. So I'm gonna do this. So this will be 75 plus 7 times negative 2.5, negative 17.5 equal to 15 VF, 7 times 4.17, 36.19. And you're trying to find this, so what I have to do is I have to subtract this and bring it to the other side. So this will be 57.5, and then I'm going to subtract 36.19 from here. That's from that. And I bring this down, and 57.36. 21.31, and I divide this by 15. So what I will get is 1.42 meters per second to the right. The reason why it's to the right is because in the problem it says the blue, it moves to the left. So the blue, it moves to the left, so that means it will be opposite momentum, opposite direction, but in momentum, so it'll be to the right. So that's that. B, it says explain, do not calculate how to determine a collision is elastic. And when a collision is elastic, that means that there is kinetic energy. Kinetic energy is stored. It's conserved, sorry. So kinetic energy is equal to, so that's elastic collision. So that means that it will be the sum of kinetic before and after. Okay. And then to see, now show a series of calculations to determine if the collision is elastic. And so, okay, so I'm going to use the equation 1/2 mv squared, because it says this is elastic collision. So I have to use that equation. So 1/2, this is 15. This is for the red, and this is for the blue. So I'm gonna plug this in the calculator. This is 187.5. So I'm gonna plug this in the calculator. Be negative 8.75. Equal, wait, I got that answer. Yep. And then this is before collision, and here's the after collision. Okay. Whoops. Okay, so this is after, so it'll be 15, 1.42 square. 1.42 is from the velocity that the red car after the collision. So that's where I got the 1.42 plus 1/2 7 5.17 square. So I plug this in the calculator. $15.123 plus 93.6, and after that I'll get 108.87. Okay, so this is the answer, and this is the answer. The last one is long, but I'll try to explain it the best I can. Okay. It's about the bullet and the pendulum, the length and the mass. So this is the length, and then this is the bullet. Okay. I'm doing a problem with this. So I'll pull my notes. So, this is going to be the beginning of the swing. and KF. This is the pendulum final, pendulum initial, and kinetic initial, kinetic final. Okay. So kinetic initial, the equation is going to be 1/2 mv squared, and this is when there's a last kinetic energy. It's elastic. Yeah. So, and then the mgh is the mass, gravity, and the height. So this is going to be the mass. And then that will equal to 1/2 mv squared f plus mghf. This is beginning. This is after. Okay. And this will be 0 because, excuse me, you don't know the the mass and the height of it, because it says a bullet hits a mass with the length and length and mass and lodges it in. When the bullet and the hits a pendulum, it swings upwards from the equilibrium position, reaches at an angle at its maximum. Determine the bullet's velocity. So these two will cancel out to be 0. So then what you have left is 1/2 mv squared equals mghf. You multiply that by 2, cancel that out. So you get mv squared equals 2mgh. This will be the final. Okay. What you do is you divide by m, cancel that out to get the V2 by itself. So then you can't have a square, so you square root it. So you square root it. And you get V equals 2gh. This is the velocity of the system. And then you're gonna use mass of the bullet, velocity of the bullet plus mass of the pendulum. Velocity of pendulum equals mb plus mp. And this is going to be the velocity of the system. So this will be 0 because this is the bullet will hit the pendulum, it will swing upwards. So that will be 0. So that will be canceled to 0. So what you have is mb vb equals mb plus mp v system divided by mb. That cancels out. VB equals MB MP. And then what you have is you put this here, 2GH. So you have VB MB MP 2GH. And this is like a trig, so arc length adjacent will be a cosine. Arc length hypotenuse equals a sine theta. And so will be sine because you're trying to find the hypotenuse. Because once the bullet hits it, the pendulum will swing up at an angle. So you don't know what this side is. The hypotenuse. So your equation will be VB MP let's go to 2GH L minus L cosine theta MB. That's the bullet's velocity.